think we can start. Welcome to this session about Micro-Frontends in AWS. Let me start with a question. How many of you have heard the Conway's law? Okay, a few of you. So for the rest of people that never heard about the Conway's law states that usually the software architecture of an application is designed in a way to represent the organization structure. And if that is the reality, now we have talked in the last 15 years about microservices, but what about frontend? The reality is that there are a lot of misconceptions around how to do distributed system on the front end, and I believe now we started to have a bit of more maturity and a bit of more understanding how to do that, and I would like to show you how can you apply Micro-Frontends in AWS. Who am I? My name is Luca. I'm a Principal Serverless Specialist Solution Architect, the longest title that I ever had in my career in AWS. I'm an international speaker and a books author. Today we have a lot of ground to cover, but first let's start with the basics. Let's try to understand deeply what Micro-Frontends are, because if you look online, you can find gazillion of different answers, and very often people that are approaching Micro-Frontends for the first time are extremely confused because they read one thing, they read another thing, and they don't understand it. So this is the definition that I coined like 8 years ago, and I still believe that is the definition that explains deeply the difference between Micro-Frontends and the rest of the more common definition that we have seen for front-end applications. And Micro-Frontends, in my opinion, are a technical representation of business subdomain, and they allow independent implementation with different technologies or same technology. They minimize the code share that are owned by a single team. So in this definition, there are a lot of words that are highlighted. So let's try to deep down and understand what they mean. So first of all, let's start with the concept of domain-driven design. So we are looking at the problem from a business perspective, not a technical perspective. And that usually leads to a follow-up like, oh, but Micro-Frontends, like I have heard several times, are just glorified components. Not exactly. Let's try to understand why. So a component, let's take the most simple example, a button, has a bunch of property. A button you can have like, you can set a label, you can maybe set an icon, it resides based on the language that you have there inside the button, you can disable, you can have rollover and so on and so forth. But who is owning all this logic? Not the button itself. It's the container of the button. The container of the button is instructing a bunch of components how to do that. And there where basically is the difference between Micro-Frontends and components. A component is leaking its domain outside and is asking to someone else to understand in the specific context how to behave. And Micro-Frontends knows how to behave. And that's why when we think about Micro-Frontends, we tend to think about independent implementations. Why that? Because independent implementations allows you to have speed of delivery and have independent teams that will move ahead with their Micro-Frontends at their own pace. And that's one of the key things. The moment that you find yourself in a situation that you need to coordinate for every release with several other teams, then it's time to go back to the whiteboard and understand how you design your bounded context is the correct or not. Several times I have witnessed in several customers that I follow that they are designing Micro-Frontends for enabling the teams to use whatever technology they want. Usually this is for me a stretch. I don't think is the right approach. We are writing code for and embracing an architecture for enabling speed of delivery and not penalizing our customers. Therefore, if you are designing a Micro-Frontend application with 2, 3, 4, 5, whatever you want, UI libraries or framework, probably there is, you need to think about your customer. There are certain, let's say, situations in the life cycle of a project where having multiple technologies might make sense. Think about migration from a monolithic architecture towards let's say a distributed system. Or think about a situation where you want to migrate from a version of, I don't know, Angular to a newer version of Angular. So in this case, you know that you set for temporary amount of time, for a certain amount of time, you penalize your users. But in reality, you are gaining a lot of traction, a lot of information, because the moment that you take one micro-frontend or bunch of micro-frontends to represent a view or a bounded context, and then you take them end-to-end through production, you start to generate value for your users, but moreover, as a developers, you're starting to learn how to operationalize micro-frontend. Because in distributed system, one of the main challenge, despite its front-end and back-end, is not the code that you're writing inside the system. The other thing that probably is controversial, and I had a lot of pushback in my experience, is usually minimize the code share. Especially on front end, we are used to do these nice abstractions. I was one of the developers doing a lot of abstractions, and there we tend to then share across the system. Reality is that vast majority of the time, abstraction are just a naive way for developers to enjoy the job that they are doing, but they are not often used gazillion of times inside the system. Therefore, we need to be aware that an abstraction creates also coupling and also external dependencies to other teams. And therefore, when we think about what we need to share in micro-frontends, but in general in distributed system, try to think on what really matters. In the case of micro-frontends, design system, logging library, or the cross-cutting concern that are really, really needed. Not tend to minimize, share immediately two lines of code that are, let's say, the same inside in different micro-frontends, because that will lead to create a nice coupling between teams. Last but not least, ownership. I truly believe that in 2023, a team should be able to own end-to-end his own bounded context. They should develop the code, they should operationalize their CI/CD, and they should create their dashboard and understand how to support let's say, their code in production. The moment that is not happening, it might be a challenge. I have seen several companies, several customers that are still working in a situation where the developers are writing code, throwing the code on the other side of the fence, someone else will operationalize for them. That might be a challenge, because they know better how to optimize the code, and if they need to operationalize a distributed system, they have to understand it deeply. The last thing is, ownership doesn't mean that only one team should contribute to this code. Other teams can contribute, but the reality is, in order to merge that code that will be supported in production by a team, only the owner of that code should take the decision to accept or not the PR. Now, when I started to think about the micro-frontend, I had also to think, back in the days, a way to simplify the understanding. And therefore, I came out with this idea of decisions framework. And the decision framework is composed by four simply things. The first one is that you need to identify your micro-frontends. So you want to have one micro-frontend per view, you want to have multiple micro-frontends in a view. I have seen both in different companies, and they have like pros and cons, but that is something that you need to think about. The second thing is understanding how to compose micro-frontends. Do you do client-side rendering, server-side rendering? Which one fits better for you? And both of them has pros and cons. So as you can see, if you're familiar with front-end, those are concepts that you are already applying day to day. If you think about a single page application or server-side rendering ones, are exactly the same thing that you're doing. But in micro-frontends is an architecture, therefore those things has to be planned and understood in advance. Then the next thing is routing. So how you're going to route. Obviously, if you go on client-side rendering, the routing part can be applicable at the client side or edge side. So nowadays, there are a lot of CDNs that allows you to have some compute that are living there. So you can intercept the request and then redirect with your own rules towards serving a specific static artifact in the case of client-side rendering. In the case of server-side rendering, obviously, you can have an application server that does that for you. And last but not least, the communication part. If you have multiple micro-frontends in the same view, very often I have seen customers starting the journey thinking, oh, we are going to create this global state and everyone will look into that. That is design time coupling. is an anti-pattern. We are familiar with that in microservices world, and you tend to avoid design time coupling because that means every time I move something, everyone else is impacted. So what we want really to have is having independent micro-frontends, and therefore state inside the micro-frontends, that they are communicating but highly aligned, and they are communicating through pub sub pattern. Publish subscribe pattern is a quite common pattern for doing so. In front end, you can express that through custom events or an event emitter, or even reactive streams if you're familiar with that and your system wants to use that. Those are, let's say, a simple way for decoupling your system and also define some contract, because you need to think about how the events are bubbling around your view. That leads us to, okay, so we understood what micro-frontends are, and we want to understand, and we have like an idea how we need to think about them. So let's try to apply those things in AWS. So the first one is this one, client-side rendering. So in client-side rendering, what we usually have is what we call the application shell, that when you call your website, that's the thing that will remain for the entire user session. And the application shell should be domain unaware. What does it mean is we don't need to have an application shell that knows inside out everything related to the domain. The moment that you leak a domain into the application shell, then you need to coordinate the deployment of application shell and domain or micro-frontend. So in this case, it might be a challenge. Here you can have one micro-frontend in the same view or multiple micro-frontends in the same view. It's completely up to you. Obviously, bear in mind having, let's say, multiple micro-frontends, not components, but micro-frontends. It means that you are going to think, let's say, also the governance side more thoroughly, because the complexity is then who is responsible for the final result, how you are going to handle the end-to-end testing, and is the team responsible for the end-to-end testing knows where his micro-frontend is used and knows all the different domains where it's used. So in this case, the application shell is also responsible for retrieving and loading a micro-frontend and also routing. So those are usually the things that you have. The output of this, because it's client-side rendering, is the holy trinity of front-end development: JavaScript, CSS, HTML. So every part of the application will be with these static files. So usually the HTML is on the application shell, and micro-frontends are usually a bunch of JavaScript files. It's not always true, but is widely the direction that we are taking with famous framework like Module Federation, Single SPA, if you have heard about them, and that's where we are going on the client-side rendering. In AWS, this is extremely simple. You can have a S3 bucket that is an object storage that you can store all your static files. And then you have a CDN, usually CloudFront, that is the offering that we have in AWS. And with that, you can scale with quite a lot. You can cache in the way that you want your files with different headers and different ages on your caching strategy, and so on and so forth. Now, before I was mentioning we can have also a bit of compute close to the edge, and in AWS we have two ways to do that. We have CloudFront functions that are, let's say, small functions that are happening before the request is what we call the viewer request and viewer response, that is happening when the request is coming towards the origin and when the response is going through the viewer. There are some limitations. You cannot do external calls in the CloudFront functions, and you have 1 millisecond of execution time. So that is for having something extremely fast. Usually we use them for redirection or for, let's say, checking that the headers has formed in proper way, stuff like that. They scale, let's say, pretty great, and they are at the point of presence of the system. Therefore, in a CDN network, you have multiple point of presences that are available all over the world, and the CloudFront function are running there. Lambda at the edge instead is a different thing. Lambda at the edge is let's say, pay-as-you-go, let's say, compute system, and is living inside the edge regions. There, basically, what you can do is using the Lambda at the edge for a bunch of interesting things. Like, for instance, you can use for applying strangler pattern for your front end when you are migrating from your monolithic architecture to micro-frontends. You can use even for applying canary releases if you want. And there are different ways that I have seen use Lambda at the edge in micro-frontends context. If you want to know more, I have a video that when I didn't work for AWS, I was a VP of architecture for a company called DAZN, that is a live sports streaming platform. And there you can see how we have, let's say, migrate our monolith to micro-frontends and how we use Lambda at the edge for canary release and blue-green deployment. Now, client-side rendering is one part, and I think we, in the micro-frontends community, we have done a fantastic job with the framework and tools that are available nowadays. There is still room of improvement, obviously, and there are things that we are exploring right now, but I believe there that we have at least a clear idea how to do that. To be honest with you, is definitely simpler than server-side rendering. Server-side rendering, the options are, let's say, almost infinite if you think what you can achieve, and therefore it's slightly more complex. So here, what we have, instead of an application shell, I call it a UI composer, not to create confusion. And therefore, the UI composer, what is responsible for is retrieving multiple micro-frontends and putting them together into a template, and then every micro-frontend is responsible to call their own API for handling this part. Now this is, if you see, it's quite simple. In the other side API, obviously, are called when they are in the browser, but here, if we can cache, obviously, the content inside the micro-frontend, you can do it in this way. Now, let's try, there is another thing that we need to think about on the composition side. There are several techniques that I evaluated for let's say, implementing and composing micro-frontends into the UI composer. So I started with node loaders. Node loaders are, let's say, a functionality of Node.js that there are some people that have created an import map that works in Node.js. Unfortunately, it's very leaky memory-wise, and node loaders went through a, let's say, rebuild from the scratch from the Node team. So still, I'm not too sure if that would be, let's say, something that I would recommend today. ES6 remote modules is another very interesting and experimental feature that is available from Node 18. The idea is the same thing that you would have like in the browser. So you can call a remote endpoint for a JavaScript file, and the system will take care about that. The problem with that is that currently works only with HTTP 1.1, and if I remember well, it doesn't support HTTPS. And the other thing is experimental, so we don't know yet how it's going to work. It might be a challenge. The next thing is Module Federation. So Module Federation is a plugin for Webpack, and this allows you to, let's say, it takes care to compose your different modules at runtime. There are several, let's say, packages for client-side rendering, for Next.js, for Node.js, and so on and so forth. Now they are, let's say, changing the underneath logic on how they are going to load different modules. But overall, you know, it's an interesting solution. I had several customers that they don't want to build on top of just one plugin. Therefore, and also, for instance, one thing that I notice every time that there is a new version, let's pick Next.js, that probably is the most popular nowadays framework for server-side rendering. Every time there is a new version of Next, the Module Federation team has to look into that and trying to change the plugin for let's say, be compliant with the new version. That for me usually is something that would I build or the entire system, maybe the key part of my application, and I need to wait for another third-party system to update despite it's open source, but do I want to build everything on top of that? It might be a risk for certain companies. Then we have Node VM modules that is built in, is available for Node for a while. So you can basically say, I have an external JavaScript and I want to, let's say, treat it as JavaScript that is written inside the same application. That opens up some security concern, and have some customers that unfortunately are very nervous when we talk about security, especially when we have, let's say, stuff that can be loaded externally into my system, and that means everything that is inside the node VM can have access to everything that I have written in my application server, and therefore all the security model that I created around the permission of my application server are granted to this external module that is, let's say, available there. So the last one that is battle tested, seen several times in different companies, etc., is HTML over the wire. So what I'm going to exchange is a bunch of HTML. That's it. Now that doesn't mean you cannot have interactivity, and we are going to see in a moment how we can fix this thing. So when we talk about server-side rendering in AWS, it's slightly more complex, as you can see here. So here we start having, for the first thing, a CloudFront distribution, more or less like the other one, and an Amazon S3 bucket, where we are going to store our data. The S3 bucket, what we are going to have there, static files. So if you think about server-side rendering, one of the key things that you have there, you have the possibility to hydrate your code. So imagine that I need to store, hydration means basically that our frameworks, let's pick React, what it does behind the scene is that you, let's say, do server-side rendering, you shove the page into the browser, and React behind the scene, when finds something to hydrate, checks that the DOM element that you built is exactly the same that you have server-side rendered, and then adds listener and any other logic that you want to do. So somehow this JavaScript file has to live and be served to the browser, and usually you do that in a way that is available through a CDN, and therefore you can use S3 and CloudFront for this kind of a situation. The other thing is I want to have a way for composing my UI, and therefore I need to build something that has some logic. So usually I have an elastic load balancer with, in this case, a bunch of containers for going to compose my application. Why I choose containers over a Lambda? So if you're familiar a bit with AWS, one of the missing features for Lambda at the moment is the fact that we cannot stream result into the browser. And this one of the features that is in the roadmap for a while, and hopefully will be released soon. But the idea here is that the Fargate will allow us to have to manage our containers in serverless fashion. So we have to take care not too much about our cluster. Fargate will take care about that for us. And the beauty of this is we can have streaming there. So we can stream our server-side render content into the browser for have better web core vitals KPIs. So what it does here is interesting. There are several arrows that are going that are starting from Fargate. So this is our UI composer. So the problem is, vast majority of the time, when we think about UI composer, we need to think a way to compose our micro-frontends. But where can I find them? I have seen several implementations on that, and vast majority of the time, everyone goes direct to a specific URL. I think we can do better. I think that having the concept of service discovery that is very well known in Micro-Frontends microservices can really help here. So we can have something like that allows us to have, I just pick parameter store because it's a very simple service that basically is providing a key value store for our system. So we just say, I want this ID of the Micro-Frontends, and then I retrieve back a URL or ARN, like is called in this case for calling our system. And then what I do here is just retrieving this information, and then I can finally start to call my Micro-Frontends. And Micro-Frontends can be expressed in several ways. It can be a container, it can be a Lambda function, it can be a step function. A step function is an orchestrator that service that we have in AWS that is a low-code implementation. Therefore, you define a state machine. We will see an example how it works. But basically, you define a state machine, and you can directly connect to over 200 services in AWS without writing a line of code. You just define what is the API that you want to call and what are the parameters, and it will take care to, let's say, communicate, retrieve the data. It handles errors, exponential backoff, retries, and so on. It's an absolutely fantastic service if you never use it. I recommend to look into that. So now, this is conceptually how it works. Let's jump into an example, because I like concrete things. So this is, why is not, hang on, because I'm in a different page. Sorry, can you check why I can see only PowerPoint and not the rest? Or maybe like this? Yes, should be. Okay, so this is the example that we have. Okay, very simple. So I mimic what you would have like a very simple page, the detail page of an e-commerce. I'm not a designer, sorry about that. So we have an header, and we have a bunch of micro-frontends that are, let's say, highlighted by the dotted line. So this is the first one. And then we have a second one, okay, very simple. We have a third one that is hidden, and that is for notification. What I can do with micro-frontends, we said that has to be independent. So for instance, the review micro-frontend has the capability to expose also some APIs through, that is owned by this hypothetical team that is looking into review. I can add, I don't know, a review, interesting book, from NDC, London, rate free, submit. Done, if the connection works. Perfect. So here we are. So we have our thing. So this one is an independent domain. The team has created its own APIs, has its own view, and does everything it has to do. In this case, instead, is different. So we have the page detail, and the item detail of this book. And then just to show you another critical things that we mentioned before, communication between micro-frontends. So there is a third hidden micro-frontend that is the notification system. Notification is completely client-side rendered. It doesn't have to do anything with server-side rendering because it behaves based on the type of signal that is retrieving from the system. So in this case, for instance, if I click buy now, I have these things that is appearing. This is the third micro-frontend that is listening for an event that is happening in the view and then reacting to that and doing some stuff. Those are three completely independent systems. I can deploy them and I don't have to communicate with the others. Obviously, this is a simple example, but you get the idea. So how it works behind the scene. Let's try to see this. Is it big enough? Okay, cool. Let's start from this part. So the UI composer is nothing more than an application server. I use Fastify as a framework in Node. Basically, when I go to the home page, that is what you have seen this example here, I basically take the catalog and then I use a response stream for sending the output of that. The catalog receives two things, a catalog template and a micro-frontend list. So basically, I pinged at the beginning when I started my application server the system parameter for retrieving all the different micro-frontends that I'm available. I can do that, let's say, at every request, but in this case, for the demo purposes, I have done the initialization of the server. And here, what I do basically is going into the catalog and composing my micro-frontend, how it works. So I want to show you that composition doesn't need to have specific tool or whatever. It can be done in whatever way that you prefer. What I created is, I thought, okay, should I use this library, that library? No, let's go with ES6 string literals. So what I can do here is I created this template, what is it? Static. That is an HTML page I called .template, just to give an idea that is just a simple template, but with one caveat. I put like some marks to say, okay, here I want to use let's say I want to replace my placeholder catalog and review, and this is where my micro-frontends will live. I can have more, obviously, but for instance, here I have the notification one. that is completely static and is served by the CDN like we have seen before. But here, basically, I can structure my template that is external by my application server. So if I change the template, I don't have to redeploy my application server and my UI composer. I just change, delegate to the team how they want to, how it looks like, and off you go. And on the other side, in my catalog, what I do is a bunch of things. So I retrieve the template, and then I created this simple, let's say, utility library called the Micro-Frontend loader that can load directly from a Lambda or from a step function. What it does, basically, is implementing the SDK, AWS SDK, for retrieving and calling directly my system. You can do with even external HTTP requests if you want, internal HTTP requests, and so on and so forth. As long as you output in every Micro-Frontend HTML fragment, you will be able to retrieve this information and compose into this template. And then there is a library that I use, very tiny. It's called the Yes Dynamic template. And what it does is just using the approach that you have seen, let's say, token for identifying the Micro-Frontend. It wasn't, let's say, a template literal, just, let's say, randomly. It was because these libraries dynamically identify in a string template literals, and we can substitute into the system. And that is where this second part, let's say, works. So I have catalog Micro-Frontend and review Micro-Frontend. But I wasn't happy only on, I retrieved this information, put inside the template, serve to the customer. I want to do an additional thing that Micro-Frontends are really good on that. I want to analyze the Micro-Frontend response. I want to understand, is it a 200 response and therefore I can take and just squeeze in, or is an error? And based on the type of the error and the importance of the Micro-Frontend, I can also decide if I want to fail gracefully, like you will see in the review part, if I'm going as a customer to see the detail of an object, and I don't have the review, yeah, I'm pissed off, but at least I can accomplish my goal potentially. And then you can provide different weight and way how to handle errors using this technique. And basically here what I do is as simple as either you throw an error and therefore the application server will return a page with, I don't know, 500. Or you can hide nicely and gracefully the Micro-Frontend that fail, and you just don't show anything. You just provide, let's say, an empty string. This is the composition part. Now, I want to show you an interesting one that is, let me see how we are with time. Yes, we have plenty of time. Perfect. So let's start with, let me see, the catalog. The catalog is the step function thing that I mentioned before. So usually in step function, this is what we call ASL, the Amazon State Language. And here you describe basically how the things works. It's not very clear if you're not familiar with that, what's happening. So let's try to use the AWS toolkit and render the graph. So this is what we do. What we do is this. So when I call my step function, the first thing that I do is checking in a database, in a DynamoDB table, if I already pre-render that Micro-Frontend, that object is not going to change gazillion of times per day, so I can cache it up front. And then if there is no data, I go to retrieve the product data, rendering, cache it, and serve. Or otherwise, if there is data, I just return the cache page. This technique that is pretty simple allows you to have an extremely fast response time. We're talking in double digits, in milliseconds. And the idea is that when you want to, let's say, query a database, in this case DynamoDB, this is the code that you need to write, nothing else. Usually in the past, before the integration of AWS SDK, what you need to do is spinning up a Lambda or having a bit of compute with the logic for query database. That was it. You just did say, get an item from the database and return the response. In this way, it's completely built in, as you can see here. You don't have to do anything else. This one, what we'll do is taking the AWS SDK, calling the API get item, passing the table name, and then in this case I hard-coded the ID because I just have this book, but you know what I mean. So you can pass whatever ID is from the composer, from the query string of the request. And then you go ahead with the logic that I showed you before. So every single part starts to, let's say, define branching logic and a zillion of other things. And a step function, you know, often, and this one is completely synchronous. So you have different type of the step function. You can have asynchronous execution or synchronous execution. This case, obviously, is synchronous because we need to build our system. Then when we go on the rendering part, this is the only code that I need to maintain as a developer. Is this one. So here what I have is taking my steps. I receive as a request inside this event object, I receive the data that are retrieved from DynamoDB. I just unmarshal them because obviously are marshal in order to have, let's say, the data from DynamoDB. I create a state inside my application that are the part. This one was a bit forced, if you want. I did that because I wanted to show that you can use exactly the same thing that you're used to do with server-side rendering. So you can create a state and append it inside the window object, and usually, classic thing, try to prefix them with the domain. And then what you can do, you can then render your page in the way that you want to apply all the dynamic logic that you need. And this is the only code that you need to maintain, because the rest is handled at the step function level. So you don't have, let's say, obviously every line of code that you need to write, then you need to think about unit integration and end-to-end testing. Here you simplify some part of that because you delegate certain part to a machine, a state machine that is step function that does quite a lot of stuff for you. Then if we see the other interesting thing here, hydration. So when I have the book, I have at central point the thing that I want to click the button and send emitting the event to the object. So what I created is this hydration part, that is this buy button that basically trigger the event into an event bus. And here what I do is this one. So I have my state, and then when I click add to cart, what I do is saying window.emitter, because I have an emitter that is global for the window, so an event bus that is embedded inside my view. And what it does is just saying emit. I don't care who is listening to that. That's the beauty of that. The producer doesn't care how many consumer will have. So if tomorrow I want to add another Micro-Frontend, then in that case, I don't have to coordinate with a gazillion of other teams. What I need to do is just understanding that there is this event in my documentation, schema, registry, whatever you want to call it, and those are the fields that are passed, and I can plug me in and then do whatever I need to react to this thing. This one, in order to be, because it's hydrated, what I need to do is isomorphic. So I use the buy component in the server-side rendering, so it's displayed, but also on the client side for hydration. So my code for hydration is basically the same code that is running on the server, but like this. This then I will hydrate in, sorry, I will use Webpack for transpiling it, and then this one will be a static file, static JavaScript file that I load when the browser loads the page. Now, as you can see, it's very tiny, so I just identify the part that has to let's say, communicate with the rest of the application. The rest is static. So I have this granularity in server-side rendering with Micro-Frontends that I can define this, and that means you're going to have, let's say, quite a few JavaScript files potentially in the page, but are really, really tiny. And the beauty of this approach is that obviously you can also defer the hydration for when they are in the viewport. So if you have like your viewport like a mobile application that for the screen is tiny, the viewport just shows a part of the page. All the other JavaScript files that are at the bottom that might or might not be seen by the user, you can defer them to load. And that therefore your KPIs in Core Vitals, they start to increase even further because you just load enough JavaScript for what you need. But as you can see, my JavaScript is not a proliferation of stuff. It's just tiny thing that I'm going to do. Then the other thing that I want to show you is a simple Micro-Frontend that is the review one. And the review one is composed by two things. So I have these get reviews, that is basically the request for retrieving the HTML fragment, and I have these post reviews. And the post is instead my Lambda function that is plugged into an API gateway that basically allows me to, when I show the form, sending the form and visualizing inside the page. That is basically the idea that one team is responsible for its own bounded context and can handle end-to-end API, front-end, wherever is needed. So in the case of getReview, this one is just a Lambda function that is querying a DynamoDB where we collect all the reviews. Here I just describe basically what I need to do. So I use scan because I know that I didn't have many elements in my DynamoDB, and then I just respond 200, or otherwise I need to let's say catch an error. And in this case I create a component reviews that is dynamically used. I forgot to tell you that I'm not using React here. I'm using Preact, that is similar as you have seen in syntax of React, but allows you to have like the hydration, deferred hydration, allows you to have very simple syntax, as you have seen, and also is 3 kilobytes instead of 32, 33, something like that. So it's very fast. And the creator also of Preact now is working on Shopify in this massive, let's say, new system that they want to build for providing super fast server-side rendering applications. In order to operate all of that, what I use is different infrastructure. If you are, let's say, familiar with AWS, you can use different infrastructure as code tools. In this case, I have used two, just to show you that obviously you can play with different, because maybe there are some teams that have different ways to handle things, and as long you maintain the same security posture and the possibility to have templates to speed up the development of your developers, you are in a good position. Obviously, you can also say, oh, I would just want to use Terraform, go with that. But in my case, I use CDK and AWS SAM. Both of them has a nice feature that allows you to, if you have a dev environment, to quickly deploy your stuff in the cloud and test immediately. So from your CLI, you just have a watcher that is looking for every time that you change a portion of your Lambda logic or whatever the serverless thing you are doing, and then automatically deploy inside your account. So when you are like you're making small changes, you don't have to rebuild, redeploy. It's using instead of using CloudFormation for let's say packaging all your asset and reprovision all the infrastructure. If you change only the business logic, the only thing that it does is calling an API that is available in the SDK and atomically update the Lambda function for you. That basically speed up drastically the development of your system, not only locally but also in the cloud. And this is basically a simple example. The code will be available online quite soon, because I'm writing currently a blog series around this thing. The first post is already out and the second one will follow soon. Let me go back here. So I leave a bit of time for questions, if there are any. So we have seen this. Okay, additional consideration. Obviously, this is what I showed you is the big body of work, but there is more. There are a few things that we need to think about. Caching layers, where we are going to cache. We have different options in the front-end world. We can cache using browser. We can use PWA, for instance, with the network APIs for doing so. We can cache on the edge with the CDN. We can cache in memory on the application server or Lambda function. So there are different layers that you can use at your own will for speed up the delivery of stuff. As you have seen also in step function, you have the possibility to store the data and cache on a DynamoDB and serve before going to recompute every time, always the same thing. So you have different ways that you can handle the caching and leverage the caching for improving the performance of your applications. Second one is consistent user interface. So one of the challenges I have asked several times in Micro-Frontends is how can I make sure that every independent team is using the same design library or design system library? And there are several techniques. One that I usually recommend is usually at some point they have to open a PR in some of a version control system. There you can have a bot that is checking, inspecting the package JSON that they are building and checking that the version of the library or design system is using the latest version. And then you can be, let's say, as compliant as you want. There are companies I've seen that they just check the major version because we are talking about a SAM-ver package. So major version, and they don't care if it's they are behind on, let's say, the minor and bug fixing. Some other companies, they want that you are at the very latest version. And therefore, they block basically the merge of the code if they are not compliant. So it's completely up to you and depends from your needs. But in this way, you can ensure having these, let's say, fitness functions inside your automations to have the latest and consistency user interface. The discoverability is an interesting topic, and I started to look into that last year, and I have quite a few ideas how to improve that. But now, for instance, today I showed you an idea of using parameter store, but it could be smarter than that. It could be a microservice where you just have all the micro-frontends that are registered in the microservice, and the microservice, in order to serve based on the ID, the ARN or the HTTP endpoint to retrieve the micro-frontend, what can do is implementing canary releases and blue-green deployment. So I can say I have a new version of my micro-frontend. I want that the new version of micro-frontend is served, I don't know, 5% of the traffic for the next 10 minutes, and then you increment based on what you see inside the observability dashboard. So you have the power, the moment that you decouple this part, to handle it in a way that de-risking your development and the deployment of your application, that I believe is a fantastic way that often is not leveraged enough in the front-end world for this, for, let's say, implementing distributed system on the front end. Automation. Okay, so now I don't know how popular will be this opinion, but I don't believe that there is a decent distributed system that can run without a strong automation strategy. Automation strategy, for me, is the first thing that you need to look at. You need to constantly iterate on performances because it's not just a way to predictably create an artifact, but moreover is a way to provide feedback loop for your developers. And feedback loop for your developers is by far more interesting because the fastest you have your automation strategy, the fastest you can they can have confidence to deploy in production. Very often, you know, we see bubbling signals around the organization like, oh, this team is super slow or stuff like that. But we need to understand we need to take them as a signal, not as an output, and trying to understand what is the root cause of this. And often, automation strategy is designed well for the first, I don't know, few months, and then forget about that when it starts to really hurt, when we have a build of 15, 20 minutes, and then I start to see that. So that if you think about that, in economy of scale, you have, I don't know, hundreds or tens of teams that are working with, I don't know, 20 minutes build, how much time you waste? So probably it's something that you need to think about. Observability is, in microservices, I think is probably the question that I heard the most, but in Micro-Frontends, not yet. Very often, let's say there is, when I mentioned few of the potential tools that could help in observability are not even known by teams. And therefore, one thing that I encourage you is start to look what is the right tool for observability for your system. Client-side rendering, server-side rendering, it doesn't matter, but this is something that you need to nail, because the moment you have multiple teams working on the same project, when you have application support calling, oh, there is an S1 incident, or there is like, I don't know in which, let's say, a grade, or how you want to call, like very important incident in your platform, who should they call? Should they call all the teams? Should they call a specific team? You need to think about observability. And when the team is there that it has to fix a live bug, they need to understand what happened. They need to understand how the user behave in order to reproduce that bug. And therefore, observability is a key part of your Micro-Frontends strategy. And last but not least, governance. all the technology part is very interesting, but the problem is there are a lot of governance around that. So we mentioned before that we want to have independent teams, but that doesn't mean for every single domain, all the teams will be completely independent. Let's face the reality. There will be some coordination, but we need to think how we can reduce them. Okay, so if you, for me, one of the key things of governance is trying to understand all the different software engineering practices that you can put in place for giving a voice to everyone in the team and also facilitate their life. And I believe this one is a quite important thing. So as I said, I started a blog series in last year, and then we had like the massive event in AWS that happened in Las Vegas, so everything freezed. And now I'm back on this. This is let's say an article that you can read. Here you can find the link if you're interested, and basically start to explain the example that I showed you at a high level. The next blog post will be starting to deep dive into the code that you can find in GitHub when the next post will be published. So main takeaways of this session. First of all, what you know about distributed system are applicable to front-end. As you have seen, several patterns are deliberately stolen from the microservices because it doesn't make any sense to rename that or reinventing the wheel, because it's just adding cognitive load to the people. So whatever you have seen on the back end, if you're lucky to work in a distributed system, you will be able to also apply partially and decline into front-end world. Micro-Frontends allow you to scale your organization with a independent team, but bear in mind that independent doesn't mean everyone is super independent 100% of the time. There is coordination. I don't want to that you leave this room thinking, oh, Luca said that we have independent teams now with Micro-Frontends, so no one is talking with each other. That's not the case. There are parts that you need to talk, but we are trying to minimize the external dependencies between teams, and also we want to create, let's say, loosely coupled systems that are highly aligned. And highly aligned means that you need to talk. And last but not least, Serverless has a bunch of different services that are available in AWS that allows you to speed up your system and simplify the scaling of your system, because we take care about that. What you need to take care is adding the logic on the system, and we will take care about the scalability part and patching the different runtimes and so on and so forth. That's all I got. I hope that you enjoyed, and I'm very happy to answer any question, if there is any. Okay.
The example you showed with the 3 panels with the website and so on, it feels like there's quite a lot of moving parts to make what's quite a simple page work. How does it look like when you have quite a large application with a lot of people that's constantly being worked on? It's got client-side routing, server-side routing. It feels like that would explode in terms of complexity very, very quickly.
Okay, so I summarize the question. The question is, for a simple page like the example that I showed, there is a lot of complexity around that. And how can we justify to embrace, let's say, a practice like this for large systems? I think large systems are probably the most beneficial one for an approach like that, and I explain why. Yes, it's true. At the beginning, there are a lot of things that you need to think about. Routing, you need to think about how I compose the page, and so on and so forth. But now, let's face it. So when you have a page like that, where, for instance, in my previous company, I was checking quite a few things like how often do we change the header? So this turns out that we changed the header 2 times in 4 years. And the footers as well. So now you have let's assume that this one is the similar to a situation like you have, and then you have like the page that is inside there. So you create some bounded contents that are fairly big, are not like small components that has to change every time. So you have like a placeholder that says this is the review and that is the catalog. Now inside that bounded context, you can iterate a gazillion of times per day. Because when you set up the skeleton of your system, you're not going to touch the template. You're not going to touch, or you're going to touch the template, but let's say sporadically. You're not going to change, let's say, the position of the element unless it's really needed, but again, it's a sporadic thing. So yes, there is some work to do in the case that you have a living system that hopefully you have, and there are some changes, but inside that context, if you design properly the bounded context, then they can operate and deliver as many times as they want. I have seen teams, and you can go as granular or as coarse-grained as you prefer. There are teams, for instance, with Next that are using a module federation and Micro-Frontends, where for them the bounded context is page or group of pages. Therefore, they keep the header and footer as it is, because that is what they want in the entire website. But then they say, okay, when you go /account or / I don't know, your user page / payment, these are the 3 domains that are assigned to your team. Go ahead and build it. And the only thing that it does is there is an effort of creating the initial part for routing, scaling, etc. But then they're completely independent. They don't have to care of all the rest. What I showed you is the end-to-end thing. But when you are everything deployed and in production, then you start to work inside that box. And you can iterate in that box in a simpler way, because I have way less to squeeze in my head. I don't have to understand the entire system. I can apply the right pattern for what I need. The coordination usually is happening with update of common dependencies. Like for instance, I speak React. I use React on everything. All the Micro-Frontends that I showed you has an external dependency of common dependencies, and therefore I don't merge them. And the beauty of this approach is basically if I need to update React, I need to coordinate in different parts. True, but let's face it, how often React release a new major version? Usually it's 1.5 years, 2 years, and also when they do that, you have, let's say, backwards compatible APIs for a certain period of time, at least for a couple of versions. So that means you have 3 years for solving that part. So if you create a mechanism that is smart enough to, let's say, inject those external dependencies into all the pages when time comes, or you want to control manually, it's up to you, depends, you will be able to have something that is extremely maintainable and modular. And yes, you can start. Usually the suggestion I have is start coarse grain. You always have time to go more fine grain and divide further the application. But if you do the opposite side, it's way more complicated, because you have 2 different styles written by different teams, and then merging them, it means trash it, rebuild it. That is far to be ideal. Cool. Any other question? So the question is if there are downsides of using Micro-Frontends. Several. The fact that I'm not here selling Micro-Frontends as silver bullet, I'm here saying up to now we had server-side rendering and the single-page applications as architecture pattern that we can use on frontend. Today we have something new. And it's not new because we want to solve all the problems of the world. It's new because there are specific projects that requires to have tens of developers working together inside the same system, and we usually, before Micro-Frontends, we were delegating to the discipline of developers to maintain a large code base and encapsulate properly the code and maintain a similar code base and so on and so forth. And we realized that suddenly after 1 year, optimistically, the code is not maintainable anymore, and everyone starts to complain, they start to slow down with the release and so on and so forth. We have seen that in the backend world, and we started to see now in 2 other worlds. One is the frontend with Micro-Frontends, and the data side with the data mesh. And as you can see now, if you put together Micro-Frontends, microservices, and data mesh, the idea where we are heading towards, or the future of this distributed architecture, is trying to have a team that is responsible for a bounded context like a small startup. And therefore, they can handle from the front end, back end, and data, and provide end-to-end exposure for that. Why this? Because otherwise, we have centralized team that has to understand very complex system, and usually, decentralized team are just a fraction of the people that you have for, let's say, developing all the rest. So what we are trying to do here is not something that you would use for a thrown away project or something like that. You are going to build distributed system because you need to scale your organization. You have tens of or even hundreds of people working on this system, and you want to provide them a capability that they don't have to queue up gazillion of features and then having an endless release cycle for making that happening.